Peace be upon you and your family. 11th Chemistry, Refresher Course Model, Unit 12, Types of Chemical Reaction. In this, now we are going to discuss the answer key under Students Activity and Assessment. Student Activity. First one is 1 mark questions. H2 plus Cl2 gives 2 HCl is an example of combination reaction. In combination reaction, two reactants, they just combine with each other, gives product, is called combination reaction. Photodecomposition reaction is caused by light energy in the presence of photon of light. That light is indicated by putting H mu on the arrow mark. A reaction between an acid and a base is called neutralization reaction. Any acid, whether a strong acid, strong base, weak acid, weak base, strong acid, weak base, weak acid, strong base, all this called neutralization reaction. The normal pH of human blood is 7.4. So, these 4 one-word question comes under students' activity. Come to the assessment part. One is, what are the names of types of chemical reaction? We have number of chemical reactions, all are very easy. Types of chemical reaction. Classification based on the nature of reagents of rearrangement of atoms. First one is combination reaction, decomposition reaction, displacement reaction, combustion reaction. We have only one type of combination reaction, but a decomposition reaction are classified into 3. One is thermal decomposition reaction, in which thermal energy, heat energy is involved to decompose a compound. Electrolytic decomposition reaction, in which electric current is used. Photodecomposition reaction, in which photon of energy, nothing but light energy, is used to decompose a compound. And also displacement reactions are of 2 types. One is single displacement reaction, another one is double displacement reaction. Combustion reaction only one type, so combustion and combinations are only one type. These are classified into double decomposition reaction are further classified into precipitation reaction and neutralization reaction. Precipitation reaction and neutralization reaction. What are reversible and irreversible reaction? Reversible reaction, reactant is converted into product and again product can be converted into reactant, is called reversible reaction. Forward and backward reaction takes place. Irreversible reaction, reactant is converted into product, but the product cannot be converted into reactant. The reaction takes place in only one direction. After 5 or 10 minutes, the reaction goes to complete. They never take back in the reverse direction. The reactants cannot be converted completely into the product. All the reactants can be completely converted into the product. Both forward and backward reactions takes place simultaneously. It is unidirectional. In only one direction only the reaction takes place. It produces only in forward direction. All the reactants are completely converted into the product. It attains equilibrium. Equilibrium is not attained. What is equilibrium? The rate of forward reaction is exactly equal to rate of reverse reaction. 5th point, it is relatively very slow, but it is fast. For example, H2O solid called ice is in equilibrium with the H2O liquid water. On heating, ice is converted into water. On cooling, water is converted into ice. 2 reactions are takes place in reversible reaction. One is forward reaction, another one is backward reaction. Irreversible reaction, carbon when burning oxygen completely converted into carbon dioxide. Assessment number 3. Explain the factors influencing the rate of the reaction. Factors influencing the rate of the reaction: nature of reactants, concentration of reactants, temperature, catalyst, pressure, surface area of the reactant. These are the factors influencing the rate of the reaction. First one is nature of reactant. How affect the rate of the reaction? The rate of the reaction changes depends upon the chemical ability of the reactant. Sodium, when added with hydrochloric acid, it liberates hydrogen, which is a very fast reaction, and forms sodium chloride. Sodium, when added with acetic acid, it also liberates hydrogen, forms sodium acetate, but it is a slow reaction. In the above reaction, HCl acid is more reactive than acetic acid. One is inorganic acid, mineral acid, another one is organic acid, ethanoic acid. Concentration of reactant, the second factor influencing the rate of the reaction. Changing the amount of reactant also increases the reaction rate, because more the concentration, more particles per volume exist in it, and hence faster the reaction. Granulated zinc react faster with 2m HCl, 2 molar HCl than 1 molar HCl. If concentration increases, rate of the reaction also increases. Temperature. Most of the reaction go faster at a higher temperature. When we increase the temperature, the movement of molecules increases, collision between the molecule increases, thereby reaction speed is increases. Because applying heat to the reactants provide energy to break more bonds and thus speed up the reaction. For example, calcium carbonate reacts slowly with the HCl at room temperature. When the reaction mixture is heated, when the temperature is increased, the reaction rate increases. Come to the third factor influencing the speed of the chemical reaction is catalyst. A catalyst is a substance which increases the reaction rate without being consumed in the reaction. In the Haber's process of manufacture of ammonia, iron is used as a catalyst. We know a catalyst is a third substance, foreign substance, which is not involved in a chemical reaction, but it is only used to increase the rate of the reaction, is called a catalyst. In the above reaction, the reaction rate increased by the addition of catalyst Fe and obtain more amount of ammonia as product. Then come to the fifth factors influencing pressure. If the reactants are gases, increasing their pressure increases the reaction rate. This is because on increasing the pressure, the reacting particle come closer and collide frequently. If number of collision increases, pressure also increases. At the same time, more reactants are converted into the product. Surface area of the reactant. More surface area of the reactants increase the rate of the reaction. More surface area means, if the reactant molecules are in powdered stage, their surface area increases, thus powdered form, more surface area of the reactant react more readily than solid reactant, less surface area. Example, powdered calcium carbonate react more readily with HCl than marble chips. Marble, nothing but calcium carbonate. Why does the reaction rate of a reaction increase on rising the temperature? Just now we discussed it. Most of the reaction go faster at a higher temperature because applying heat to the reactant provides energy to break more bonds and thus speed up the reaction. Calcium carbonate reacts slowly with the HCl at room temperature. When the reaction mixture is heated, the reaction rate increases. Come to one problem. Calculate the pH 5 into 10 power minus 5 mole power minus 1 solution of dilute H2SO4. Dilute H2SO4, an acid is a substance which when dissolved in water provide H plus ion. Sulfuric acid has 2 H plus ion. 1 H plus ion is donated to one water molecule, another H plus ion is donated to another water molecule. Therefore, sulfuric acid is converted into SO4 2 minus ion. 1 H plus, another H plus is absorbed by water molecule, form 2 molecules of hydronium ion. Sulfuric acid concentration is given as 5 into 10 power minus 5. Number of moles of sulfuric acid is 1. So, in this reaction, number of moles of sulfuric acid is 1, sulfuric sulfate is 1. Therefore, this concentration is also 5 into 10 power minus 1. By writing the concentration of water molecule and hydronium ion, their number of moles is 2. Therefore, this concentration value is multiplied by 2. 2 into 5 into 10 power minus 5. There also 2 into 5 into 10 power minus 5. To calculate pH, we require H3O plus ion concentration. Therefore, these values are not required. This value is required. 2 into 5 are 10. So, 10 into 10 power minus 5. 10 means 10 power 1. That is equal to 10 power minus 4. Now, the formula used to calculate pH is pH equal to negative logarithm of H plus ion concentration or H3O plus ion concentration to the base 10. That is equal to minus log of H3O plus ion concentration 10 power minus 4 to the base 10. You know log B power A formula, log B power A equal to A log B. Now, they bring the 10 power minus 4 to the front side, it becomes 4, minus into minus becomes plus, log 10 to the base 10. You know what is the value of log 10 to the base 10? Log 10 to the base 10 equal to 1, 4 into 1 equal to 4, pH of 5 into 10 power minus 5 mole power minus 1 sulfuric acid is 4. Because of pH is less than 7, it is acidic in solution. And my dear students, in this video we discussed the answered key for types of chemical reaction part. Thank you for watching. If you like, please subscribe. Thank you very much.